hi everyone. Bearing in mind that I'm the only thing between you and drinks, let's get this going. If you cannot see my face directly, you can see my face in the slide. So I'm Rita. I work for NVIDIA as a solution architect. Most of what I do connects to evaluations. I'm going to talk about agentic systems and evaluation, but feel free to find me outside of this room and ask me about what I think about the benchmarks that we currently use. My background is space engineering, so also don't tell me that it's not rocket science because I really hate it. Everything is complex. Okay, especially generative AI. So let's start from the beginning, which is the latest in artificial intelligence. I think you may have seen this or a similar slide today before, but there have been many phases to generative AI. First, we had the LLM boom with ChatGPT in 2022, and then the adoption of LLMs. Then we were talking about RAG systems, and we're still talking about RAG systems, if my job has anything to say about it. And finally, now we're going to be talking way more about agents. It's not that we've solved the LLMs and RAG system problems, but now we decided that beyond just connecting an LLM to a vector database, maybe we want to connect an LLM to a bunch of other different stuff with different protocols, which makes everything much more complex and makes all of our jobs much harder, but also hopefully our lives much better in the future. Okay, so how do AI agents work? At a high level, what an agent does is use reasoning and planning to solve multi-step problems. And the way it works is through a few core components. One of them is what we call thinking, but of course it's thinking like a machine can think, and that's mostly enabled by reasoning capabilities. So the capabilities of an LLM to go through a chain of thought, step-by-step problem solving. Then we have, of course, prompting, which starts from a user's goal or question and interpreting intent. And then we have what I mentioned before, which is the tool use, which is calling different APIs, calling the web, calling any kind of dashboards, computer use, and memory, of course, which we may also want to implement. And finally, we have collaboration as well, which means that we may want our LLMs to speak to each other. And again, speak is a very loosely used word here. So this is a good conceptual understanding of what agents can be, which basically means that we're taking an LLM and we're adding a lot of different tools and software on top of it, basically to gain observability, monitoring, evaluation capabilities, and for it to be essentially an end-to-end scenario that users can use to develop their applications. So let's talk a bit more about the software that's necessary for agentic implementations. As I'm representing NVIDIA, I'm going to talk a bit about what NVIDIA has for agentic systems, and we tend to split this into three different components. The first one are the NVIDIA NIMs, which are essentially models that are containerized in a microservice. We have a lot of open source models and also proprietary models in our NIMs. Then we have the AI blueprints, and the blueprints, and I'm going to do a demo by the end, are our reference architectures for different AI pipelines. So for instance, research agents, customer service agents, etc. And by reference architecture, I mean that it's an implementation using particular libraries and models, but you can go and modularly change them out. So it's just a reference for developers to then improve upon. And finally, we have NeMo, which is a software suite composed of both SDKs and microservices, whose goal is to basically serve all of the components of an AI pipeline, from the data curation with NeMo Curator, to customization, which is a post-training library, to evaluation and guardrails. Evaluation, of course, is to evaluate models with academic benchmarks or with user-brought custom benchmarks, or also with LLM as a judge. And finally, guardrails are to control basically the inputs and outputs of the LLM to whatever degree we want. Connecting all of this is our most recent agentic library, which is what I'm going to be talking about here, which is the NeMo Agent Toolkit. So NeMo Agent Toolkit is open source, so you're free to check it on GitHub or on our own website, build.nvidia.com. And the goal is to basically make agentic implementation less complex. It includes everything that I've mentioned before, from the monitoring, tooling, observability, and also evaluator and guardrails. And it is modular, flexible, and also is integrated with very different components. One of them is Weave. So the integration with weights and biases Weave is what I'm talking about here today. Let's talk about it. So the weights and biases team has developed Weave to make it easy for organizations building Gen AI end-to-end pipelines to monitor and evaluate and essentially have a continuous eye into what's happening into an AI pipeline. And so the capabilities include tracing, running and tracking evaluations, and finally it's framework and LLM agnostic, so you can integrate any model with it. And one of the reasons I'm here today is because you can integrate it with the NeMo Agent Toolkit. So here is very small, so I apologize for that. The typical workflow to build an agent, but in here basically we just show all of the steps of monitoring and observability, both on an automated side and on a manual side that you can also implement. And what NeMo Agent Toolkit does is it produces those traces. So it runs the agent logic, it collects events and defines exactly the metrics that you want to measure. And what Weave does complementarily is handle the logging, the visualization, and experiment management. So basically we have NeMo Agent Toolkit as an instrumentation plus runtime for agents that you may want to implement. And Weave adds the observability and visualization layer. So here is an example of the integration you may have. Again, maybe a bit small for you, but essentially this is one of the dashboards that allows for you to check the evaluation for a particular agentic application. So let's look at some examples. First one is one of the blueprints that we have internally and also on GitHub, so it's open source. It's called AIQ. This agentic application is a research agent. So what it does is deep research, and you may be familiar with this from Gemini deep research or ChatGPT deep research. Deep research is basically a name used everywhere for when you want to build, when you want to do a lot of different searches and collate information into a very extensive, let's say, report. And so this is a blueprint, which I've mentioned before is a reference architecture. So you may, when you use it, you are free to basically change the LLMs, change any kind of libraries, and see if it makes more sense for your application. So the AIQ blueprint searches many different sources and the web to synthesize hours of research into a concise report, as I've mentioned, and is currently the top-ranked open agent on Deep Research Bench in Hugging Face, so feel free to try it out. And the one I'm going to speak about with my limited time mostly is the Alert Triage Agent, which is also one of our blueprints, and this one we have integrated with Weave. We have a blog post about it that I recommend. It's very interesting. And the goal here was to automate the monitor and action of alerts in large-scale environments. So this saves a lot of time in manual checks when you have a large-scale implementation of a software scenario where you have different fail points that you need to constantly check for problems or any kind of corner or edge cases. So as an alert agent, this requires a lot of diagnostics for hardware, telemetry, and service health. And you can see them here also on this diagram if you are able to see a very small screen. And with NeMo Agent Toolkit, you can implement and evaluate any custom metrics for this kind of application. So here is also an example of the tracing and evaluating that you can do with Weave here in these plots. But what I really want to get to is the demo, which I'm not going to be speaking, but there's going to be sound. This is about 4 minutes, so please bear with me. And it's going to be showing how the implementation of the alert triaging system works with Weave.
I'll demonstrate how to evaluate a dataset of alerts using the alert triage agent example from the NVIDIA NeMo Agent Toolkit repository. Here's the configuration file for the alert triage agent workflow. I'll run 2 evaluations, one using the Llama 3.1 8B model and the other using Llama 3.3 70B. We'll use weights and biases Weave to analyze the runs and view the evaluation results. Let's start the first evaluation with the Llama 3.1 8B model. In the evaluation logs, you'll see the URL for the Weave dashboard. The first run is complete. Now launching the second evaluation using Llama 3.3 70B. Both runs are complete. Let's take a look at the results in the Weave dashboard. By default, the Weave dashboard displays the trace logs for each run. I'll switch to the Eval tab in the sidebar to view the evaluation results. There are several runs here from earlier experiments. I'll compare these two, Llama 3.1 and Llama 3.3 results. We are evaluating 2 metrics, classification accuracy. A custom evaluator builds for the alert triage agent, and RAG accuracy, which is the built-in RAGus evaluator. Across both metrics, we see an improvement in accuracy. In addition to accuracy, the summary tab displays key performance metrics, such as the LLM latency, the P95 workflow runtime. This represents how long it takes to process a single entry. Total runtime, the overall time to process all dataset entries. As we are running the dataset entries in parallel, we can see that the total runtime is close to the P95 workflow runtime. Total tokens, this is the token usage across the entire dataset. Now let's go to the dataset results tab. Here you can pick and plot any metric across different runs. You can also inspect detailed per entry results in the table below. In addition to these evaluation results, you can view all the tools and LLM calls made by the workflow via the Traces tab. You can pick an evaluation run here. To view the individual entries, you select the table of child calls. In this table, you can select a dataset entry and view a detailed breakdown of all the calls made by the workflow.
Hopefully it was useful. Essentially, I realized I didn't speak a lot about evaluation because in this particular case, you may choose your own evaluation metrics. The demo included classification accuracy, and RAG as metrics, which are of course included in NeMo Evaluator, which is integrated into NeMo Agentic Toolkit. There's a lot of different metrics and benchmarks in NeMo Evaluator as well, including tool calling metrics, agentic benchmarks, and also the regular academic benchmarks that you know, like AME25. I'm happy to talk about that after this talk, but the key takeaways are essentially that NeMo Agentic Toolkit allows you to do a lot of the heavy lifting on creating agents, especially regarding evaluation, profiling, and all of the tool calling. Integrating with weights and biases Weave allows you to have those dashboards and observability that are always necessary when implementing an end-to-end AI solution. And if you want to know more, because this is only a 20-minute conversation, everything that we have presented here is open source, so you're free to check GitHub for that. Of course, models have to be deployed. For the AI Deep Research Blueprint, you have here the QR code for the NeMo Agent Toolkit as well, and for Weave in the end, although I'm sure you have access to it very easily. Anything else you can find on the build.nvidia.com website, which is a fairly fun website also to try out different LLMs. And that's it for my talk. I think right on time, so thank you.